Chapter 6, Checkpoint Quiz 1, Algebra 1. Problem number 1, 2, 3, 4, and 5, because 5 is asking about rate of change. Those questions is asking you to calculate the slope, which basically means subtract the y-coordinates on the top and the x-coordinates on the bottom. If it's just a slope problem, all we need is a numerical fraction answer. If it's a rate of change problem, then we usually divide the numbers and leave the units. Number 1, to calculate the slope, a slope abbreviated by the letter m. We're going to take the difference in the y's, so I'm going to go 3 minus negative 2. I've decided to go from this one to this one, which means my denominator has to be a negative 1 minus 6. 3 minus negative 2 would be 5, because minus minus gives us the plus. And a negative 1 minus 6 more is a negative 7. I don't leave fractions with negative signs in the denominator. If there's only one negative sign, I put it out front. The slope there is a negative 5/7. If somebody were to say, what does a slope of negative 5/7 mean? That means from any point on the graph to find another point, you could go down 5 and over 7. Number 2, calculating the slope, difference in the y's, 5 minus 2, over difference in the x's, 4 minus 0. 5 minus 2 is 3. 4 minus 0 is 4. A slope of 3/4 means to go up 3 and over 4. Problem number 3, calculating the slope, difference in the y's. For number 3, I'm going to use negative 3 minus negative 7 as my numerator, negative 3 minus negative 7, and the denominator, negative 2 minus negative 1. Negative 2 minus negative 1. A negative 3 minus a negative 7, which is plus 7, would be 4. And a negative 2 minus a negative 1 would be negative 1. That gives me a slope of negative 4. And a slope of negative 4 means to go down 4 and over 1. No denominator. The denominator is 1. Number 4, calculating the slope. We have difference in the y's. I'm going to go this way, negative 4 minus 5, so I'm going to go from here to here. The denominator is 4 minus negative 5. A negative 4 minus 5 is a negative 9. 4 minus a negative 5 is 9. That gives me a slope of negative 1. Down 1, over 1. That's what a slope of negative 1 means. Problem number 5 is a real-life problem. It talks about two different situations. In 1990, there was 534 billion. So in 1990, there was 534 billion. And in 1994, there was 1.021 trillion, which is 1,021 million. And so that is a little confusing there. On the test, I'm not going to give you, or on the quiz, you'll know what has to go where. It says the rate of change. Let's calculate the slope. Difference in the y's. I'm going to go this direction here. I'm going to go 1,021 minus 534 over 1994 minus 1990. 1021 minus 534. I need help there. I don't know what that is. I'm guessing it's 400 some. No. Yeah. 4 what? 487. Divided by, I don't need help with that one. That's 4. And so, if it says rate of change, we're going to divide these out. And we should get an answer of about 121.75. And now what are the units here? Well, the numerator is in billions of dollars, and the denominator is per year. So that's the rate of change. We're increasing, basically, the amount charged on a credit card by 1.21 or $121 billion more each year. In case you're wondering, that's a lot of money. I'm going to graph questions 6 and 7 by using the slope-intercept form. Question number 6, the y-intercept is -1, so I can put a dot there. The slope is 4, meaning to go up 4 and over 1, and then all I need to do is graph or connect those 2 points with the line. Now, scale on my graph here, so you'll just have to trust me that I've counted correctly. You should be able to see your graph and basically see that that's the case. Question number 7, slope-intercept form again. The y-intercept is 6, so I will count up to 6 and put my dot there. My slope is a -2/5, which means to go down 2 and over 5. Now I have 2 points on the line. I can now draw the line through them, of course with a straight edge, and there's what my graph looks like. Where questions 6 and 7 were in slope-intercept form, questions 8 and 9 are in standard form. The x and the y are on one side, and the constant or the number is on the other. So when we solve a problem which is in standard form, you want to set up a t-chart, that's fine. I'm not going to do that. Oh, I am going to set up a t-chart, but I'm going to find the intercepts. Standard form, that's the easiest way to graph. So using what we call the cover-up method, when you make x 0, that's gone. So what that really says is when x is 0, that means the 3y equals -30, and so that's going to give you a y value of -10. So when x is 0, y is -10. There's 1 point on the line. The next thing I'll do is make the y 0. And if the y is 0, then the 5x equals -30, which means that you're going to have a -6 as your value of x. So I'm going to put a dot at -6 and 0. That's all I need. 2 points determine a line. I will now graph the line connecting those 2 points. Question number 9. Again, slope-intercept form. 2x minus 7y equaling 15. Or not slope-intercept, standard form. Standard form, easiest way to graph is to find the intercepts. Now there are people who aren't going to like this, because when you put values of 0 in, you're going to get fractional answers. But in this case, I would say, go ahead and get a decimal answer. Graphing decimals is a little bit easier. So let's put 0 in for x. That would give me 2 times 0 minus 7y equaling 15, which means -7y equals 15, or y equals 15 over -7. And when you divide that out, you're going to get a value that's probably just a little bit over 2, like maybe -2 point, help me out there, 1/4. So we'll just round that off to be a -2.1. Okay? So that's the y-intercept at about -2.1, and we're getting a general idea of where the graph is. So x is 0, y is -2.1. That's right there. Now when we make the y value 0, that gives us 2x minus 7 times 0 equaling 15. So that's gone. So if the 2x equals 15, then x is equal to 15 divided by 2, which is 7.5. And so that point is where we get 7.5 and 0. That's out there. right on the graph. Perfect. Good. And then to graph that, I will connect those two. Now, if your graph is in that general location, you may have set it up differently. That's fine. I'm always going to use finding the intercepts when their equation is in standard form or slope-intercept form when it's set up that way. The last problem, how are these graphs alike and how are they different? The first thing I notice is that all three of these equations in problem number 10 are in slope-intercept form. In other words, y is by itself, the y is equal to that. The next thing I notice is that each one of them ends with plus 5, which means the first part I would say is that all of the graphs have exactly the same value of b, which is the y-intercept. So let's find that. 1, 2, 3, 4, 5. Every one of these lines goes through that point right there. What's different about each of the lines is their slope. So I'm going to graph the first line in red. All right. Let's find the second point on the line. It says y equals 3x. So starting here, I'll go up 3 over 1. There's my second point on that line. And so that line, when I graph it, is going to look like that. The next line I'll do in green, Merry Christmas to you. That also starts at 5, but that has a slope of 2/3, which means to go up 2 and over 3. So that line's going to go through there. Ooh, that didn't turn out very well. That line's going to be there. The last line, which we'll do in yellow, has a slope of 3/5. So that's up 3 over 5. And so that's going to be about right there. And that line is going to look like that. For this question, you did not have to graph them necessarily, but you would say how they are alike. They have the same y-intercept. How are they different? They have different slope.